Hey CS, this is Mr. Roberts, Shasta High School. And sometimes when everything's important, nothing's important, right? It's hard to know what to focus on. So I wanted to talk about how we do things like a fixed number of times, looping. And I created a kind of a quick scenario here where I'm gonna um, try and do some loops. So let's say, for example, that I want to do something 5 times, 4 times, or 3 times. I want to do something a certain number of times. One of the things I could do is I can have, a method, a behavior, if you will, for a class that takes a value and I wanted to do something count number of times. So let's say what I wanted to do is something as simple as just print the phrase hello class, so many times, count number of times. One of the things I can do is, of course, we've seen this, right? While something is true, do something like we could say system.out.println. I'll just say hello class. And oops, got to close the quotes, close the parens, and then a semicolon. So the problem with this, oh my gosh, is there a problem with this? Oops, we got to close the while loop. There we go, close the while loop. Okay, so the problem with this is, of course, it's not going to do something count times. It's going to do this forever because count is set to true, and it's never going to change away from being true. So if I was to compile this, and then I was to create an instance of this, I could call this method called loop1. So if I do void loop1, I can see that it wants me to tell it how many times to do something, and I say 5, but it proceeds to do it again, and again. And literally it's just throwing all these words down on the stack, and I have to come in here and I have to tell it, stop the virtual machine, stop that. I have to clear this because it did it a lot of times. So that didn't do it 5 times. It would keep doing that until, well, until, as they say, the cows come home. But I don't know what that means because I've never been around a place that has cows that return to the house at night. I'm what you call a city dweller. So what I'm going to do now is I'm going to attempt to do something a certain number of times. So what I'm going to do is, check this out. Count is how many times I want to do this. I may not have this just right, but I'm going to try this. I'm going to say, look, I'm going to say while let's do this. Let's say int c is equal to count. No, I'm going to start c at 0. So I've done it no times. So what I'm going to do is I'm going to say while c is less than the number of times that I want to do this thing, right? Well, c is less than count. So if you think about it, if I want to do something 5 times, and when I come in, if count is equal to 5 and c is equal to 0 at the beginning, that will be true, right? The problem I have is that right now count is never, or c is never going to change. So it'll always be true that c is less than 5, that 0 is less than 5. But I'm going to come in here, I'm going to say, hey, c is equal to c plus 1 more, right? Oops, c is equal to c. I didn't want to do that. What happened there? Let me go back to screen 2. C, there we go. C is equal to C. I can't, I don't think I can type, let me just do the C++. There we go. So I'm incrementing C by 1. So C starts out at 0, then it goes to 1, 2. Now, let's see if this gives us something closer to what we want. So I'm going to come in here and compile it again, and I'm going to ask it to, let's see, I'll create an instance of that thing. I'm going to call its loop method. I'm going to give it the number, I'll give it 4. And it does 1, 2, what? It did it 4 times. Let me try that again. Let me say, let's do it 6 times. 1, 2, 3, 4, 5, 6. So we've got this, right? So one way that I can control how many times something happens is by using this while loop, where I have a variable that is basically starting out at 0, and I'm comparing it with the number of times that I'm asked to do something. So I'm just looking at this count. And as I go through here, oh, I don't see my cursor. As I go through here, at first C will be less than 5, and then C will be it'll be 1, and eventually it's going to get to where C is no longer less than counted, and it'll kick out. So that's one option that we have, and that's something that we've kind of talked about in terms of a while loop, except we pretty much just always continued. Let's look at another way that we could iterate. I'll do that. I'll call this public void. I'll call it loop 2. And loop 2, let's see. For right now, I'm going to make loop 2 not take an argument, right? So this will be, oh, you see it. Like, see, I've got something right here where I'm calling loop 1. I'm calling loop 1 with a single argument, right? I need to give it a value to pass it. But you can see loop 2 here, I'm calling where I give it no arguments. So in loop 2, what I'm going to do is I'm going to use another structure called a for loop. So it's going to look like this in terms of syntax. We start with the word for, and then we have 3 things that we need inside of it. The first is our iterator. So I'm going to say int x, and I'm going to set it equal to 0 to start with. And then we need a statement where we compare what's happening in order to know when to get out. So I'm going to say, let's do this. For int x equals 0, let's go as long as x is less than the number 5. Okay, so as long as x is less than 5, and then I have to have my increments, I'll say x plus plus. So those 3 things go into for loop, right? First of all, you create the variable that you're going to loop with, and then you say do something as long as this is true, and then you're incrementing that variable. So those 3 things go into the for loop. Okay, and then let's go to the body of the for loop. So here is, oops, there's the body of my for loop. So what am I going to do inside of that loop? That's an interesting question. Well, let's try this. Let's just make it print out. Instead of that, we'll make it print out some numbers. So I'm going to say system.out.print. And I'm just going to have it print out. Well, let's just have it print what x is. That way we can kind of track it and see what's happening here. I think, right, x is going to be 0 the first time. And x will be 1, it'll be 2, it'll be 3, it'll be 4. But the interesting thing is, when it gets to where x is 5, 5 is not less than 5, so it will stop. This should be everything from 0 to the number 4, 0 to 4. And what's kind of fun about that is if something is going from 0 to 4, there's 5 things there, right? There's 0, 1, 2, 3, 4, 5. So when I'm iterating something from 0 to 4, there's 5, right? Because it's like I count 0, 1, 2, 3, 4. 0 to 4 is 5 things. So let's go ahead and ask, let's compile this again. Compile. I'll create a new one. Let's see, there we go. And just to be fun, I'm going to go ahead and call loop 1, and I'll say do it twice. Hello class, hello class. And then let's come over here and call loop 2. 0, 1, 2, 3, and 4. That's great, right? You can see x starts out at 0, and because of this x plus plus right here, that's where I'm incrementing that variable. So it hits the values 0, 1, 2, 3, and 4. So let's say now that I want to do this where I'm going to pass it a value. So I can say, int num. So now I'm going to do this loop as long as x is less than num. So now it's very similar, right? But what's different now when I compile it and I create an instance of this thing, when I call that method public or void loop 2, it requires an integer this time that's going to call num. And if I say 6, it's going to start with 0 and then 1, then 2, then 3, then 4, then 5. So 6 things ordered from 0 to 5. So starting x is 0, keep going as long as x is less than num. Another thing I can do is, I clearly printed that number there, but I can also do arithmetic with the number. So let's say that I wanted to do something like, I'll square it. So let me just come in here and do this. I'm going to go ahead and concatenate that with this little string. And this is a funky escape sequence for a tab. So it's that \t, close that off, and then plus, and I'm just going to go x times x. I could do math.square, and then I could give it x comma 2, or math.pow, math.pow and then x comma 2. But this should give me the numbers, and then next to it, it should give me the square of those numbers. So let's go ahead and do the same thing. I can compile it, create an instance of it, and I'm going to call the loop 2, and I'm going to give it the number 5. And when I do that, you can see it's got 0, 0 squared, 1, 1 squared, 2, 2 squared, 3, 3 squared, 4, 4 squared. You know, and the beautiful thing about the computers is like they don't get so, I mean, there is a limit here for as far as what an int can hold, but if I call that again and I'll give it the number, I don't know, let's just go to 20, right? So you can see what happens here on this list: 0, 11 squared, 12 squared, 13 squared, 14. I know those. 15 squared, I know. Beyond that, I don't know. I know 15 squared is 225, 16, 17, 18. Oh, and see the last one was 19 there. So you can see because it says when x is less than num, keep going as long as x is less than num. Now let's say that I wanted to shift it and I wanted to start at the number 1 and I wanted to include the last number I gave it. So I could say less than or equal to. So this now says x is going to start at 1 and I'm going to keep going as long as x is less than or equal to num. So you can see before I was starting at 0 and then I was going to 1 less of num. Let's see what effect this has on our beautiful, beautiful code. So let's go, that's right, good, good. I'm going to call it with 5. And when I do it, you can see now because I changed this to x is going to start at 1, right? Because I changed it to that, I've got 1 and 1 squared, 2 and 2 squared, 3 and 3 squared, 4 and 4 squared, 5 and 5 squared. Because I also say that keep going as long as x is less than or equal to num. But for reasons that are not entirely obvious to you right now, and somehow they're mysterious to me, I just feel more comfortable with leaving it like this. It's strange, I know. And I think it has something to do with how strings are handled in Java, but I'm going to leave it like that. One more thing I want to show you is this. We don't have to count by 1, right? So this thing right here, this increment, doesn't have to be x plus plus. I could do this. I could say x is equal to whatever x was plus, and I'll say 2. X is equal to x plus 2. Okay, so think about this. Let's do this. I'll compile a new one. Gotcha. Bring it in here. Loop 2. And I'm going to say I'm going to go to 7. So what's gonna show up? Well, I know it's going to start with 0, 0, 0, and then it's going to go to 0, 1, 2. So it's going to go 0, 2, 2, 3, 4, 4, 4, 5, 6. X is gonna increment by 2 each time. So it will start at 0, and it's gonna go up to the last one where x is less than num. And num in this case, I'm gonna give it the number 7, but it's gonna count by 2. So take a look at this. Oh, 0, 2, 4, and 6. Starting at 0, add 2 to it, you got 2. Add 2 to that, you get 4. Add 2 to that, you get 6. And where do we stop? We stop at 6. Why do we stop at 6? Because if I add 2 to 6, I'm at 8. And 8 is not less than num. Well, that's all I got to say about this. And why am I talking about this? Oh, get back to the turtle, right? Good job with your turtle. Good work with your turtles. We're going to do more with those things, but I think having the ability to do some loops now early might be helpful. This is Mr. Roberts. Thank you for watching. They always say things like, please click subscribe or share this with your friends. Don't share this with your friends. But I'll see you again later in class, preferably. Bye.